This is lesson 2 of waves. Last lesson you did this bit. Now today we're going on to look at reflection of waves in detail. So this is the document you're going to complete. We've got some keywords here. You're starting with the Quizlet from last lesson to review the keywords then. And this is a key diagram for you. We're looking at how the ray of light we talked about in our last lesson, straight line, arrow showing the direction. When it hits a plane mirror, now plane is a key word, it means flat. Mirrors could be curved that way, they could be curved that way. This is a flat mirror. So when the incident ray, and incident means hitting or coming into, when the incident ray hits the plane mirror, it is reflected off the mirror. Here we have the reflected ray, again, straight line with an arrow on it showing us the direction. In the middle here, we have a line which we call the normal. And the normal is a line at right angles, at 90 degrees to the surface here. Normal is an old word for at right angles too. So if we were to do this, we were to shine light in to where the mirror and the normal meet at this point. And we were to plot the line as it comes in, the ray as it comes in, and the ray as it comes out. If we measure these two angles, the angle between the incident ray and the normal, which we call the angle of incidence, and the angle between the reflected ray and the normal, which we call the angle of reflection, we would find that those two angles were always the same. Now, of course, the measurement will have some error in it, so they won't be absolutely perfectly the same, but that pattern would show that the angle of incidence equals the angle of reflection every time. Now, let me take you to the presentation that you're going to work through here. This is on Classroom for you, along with that document we were just looking at. So we looked at reflection last time, where we looked at how you can have the sort of regular reflection, which we're getting today from the plane mirror, the flat mirror. And we also looked at the scattering effect of having a rough surface. Look back at that if you're not sure. So here you have the normal. We'd normally, if you'll excuse the pun, we would usually draw that as a solid line, but this dotted line is fine. Dotted lines do mean something else in these diagrams. We'll come back to that at GCSE. So here you have the incident ray, and note it's a key term, incident ray, and the reflected ray, again, key term, reflected. And you have these two angles. Now, one of the most common mistakes that's made is that it isn't this angle that gets measured, but it's this one. This is the angle of incidence. This is the angle of reflection. Not this one, not this one, okay? So, there's your first learning objective. If you go back up here, you can say we had these 3 learning objectives. There's your first one, identifying the angles of incidence and reflection. Now, I've left this in here in case you want to have a go at doing it. You'll need a flat mirror. You'll need maybe a torch with a piece of paper over the front of it with a little slit cut in it to give you a nice fine beam. And you'll have to have a protractor to measure the angles and also to get your normal in the right place. But if you can do that, that'd be great. You'll see for yourself that the angle of incidence and the angle of reflection are the same if you do it several times. Whatever this one is, make this one bigger, that one gets bigger, they're always the same. So that leads us to the law of reflection, that the angle of incidence equals the angle of reflection. You need to know that. Uses of that then. Well, here's a great use of reflection. Light might come in here, strikes the mirror, top mirror, gets reflected down, strikes the bottom mirror, gets reflected and into the eye. So I can put my periscope up against a wall, so only this bit is over the top, and I can see what's going on over the wall. Or in a trench or in a submarine. So the submarine doesn't have to surface for someone to see what's going on up there. They can come to periscope depth, which is many meters underneath the surface of the water, and they can see what's going on without having to surface and put themselves in danger. And as a kind of an aside, but it's interesting, here we have rays of light coming into the eye. At the front here, we have the clear bit of the eye, which is curved, which makes the light bend. And then we have the lens, which we can control the thickness of, which makes the light bend. And so you get your image. In this case, this cross, if it was going to be a nice sharp image, where these rays meet needs to be here. But in this case, the image will be blurred because the rays are meeting before the retina, where all the light sensitive cells are. And here's the optic nerve, and this is where the nerve impulses go to the brain, and the brain makes sense of what the eye is telling it. So here we have some key terms which you can then put into that first document that I showed you. And there's our third learning objective, explaining the terms of normal, angle of incidence, angle of reflection. And here I have a little exercise for you. The answer is on slide 16, but have a go at this. I've said here, it's easier if you print it, but have a go at this. This is where the light's coming in. We want the light to get to here. So we want to mark in how the light behaves. Okay, so take a look at the treasure hunt if you can. Okay, so